Okay, this next question is a bit strange. We're asked to factorise this thing completely, and whilst it looks like quadratic factorisation, it really isn't. What I'm going to do is look at all three of these terms and realise that they all have a common factor of 3x. And if I factorise 3x out of 12x squared, I get 4x. If I factorise 3x out of 15xy, I'm going to get plus 5y. And if I factorise 3x out of minus 9x, I'm going to get minus 3. There are no common factors left in these three terms, so I'm done. Let's look at the next problem. Factorise completely x squared minus x minus 132. I want to split this into two brackets, put an x at the beginning of each one. I'm looking for two numbers that multiply to make 132, and they're going to subtract, because there's a minus over here, to make 1. X by itself is, of course, 1x. Two numbers that multiply to make 132 and subtract to make 1 are 11 and 12. To make a minus 1, we would use a minus 12 and a plus 11. And that's that problem. Now I have a question that asks us to solve by factorising, and this is a question with a number in front of x squared, so we're going to go big, then go home. Go big means I need an answer which is too big, specifically 3 times too big. I need two numbers that multiply, not to make 20, but to make something 3 times bigger, to make 60. And because of all the extra 3's I've already used, I can still subtract to make 7. Two numbers that multiply to make 60 and subtract to make 7, that's 12 and 5. To make a minus 7, we'd need to subtract 12 and add 5. So now I've gone big, and that has to be followed by going home, by which we mean that this answer is 3 times too big. I need to divide by 3 somewhere to make it the right size. I could divide by 3 in here, but that would lead to horrible fractions and decimals. Dividing by 3 in here makes much more sense. X minus 4 from this bracket, 3x plus 5 from this bracket, and this is my factorisation of that equation. I now need to solve the equation, and that means looking at each factor individually. Either x minus 4 equals 0, which means x equals 4, or 3x plus 5 equals 0, which means eventually x equals minus 5 over 3, and a fraction is the best way to represent that solution, so that's how I'll leave it. So looking at the next question, this is a friendlier factorisation. I need two brackets with an x at the beginning of each bracket, two numbers that multiply to make 22 and subtract to make 9, that's 11 and 2. To make a plus 9, it's a plus 11 and a minus 2, and then each of these brackets could equal 0. So either x equals minus 11 is one solution, or x equals 2 is the other solution. Finally, we've got to factorise this thing completely. We might recognise at this stage that it's something to do with the difference of two squares, but I'm actually going to have to do this in a couple of stages. The first stage is noticing that both of these terms have a common factor of 2. So I'm going to factorise out a 2, which leaves x squared minus 9. This is clearly the difference of two squares, x squared and 3 squared. And remembering the rule that we used before, this is going to become x plus 3 and x minus 3. So there's this expression factorised completely. And that's the end of this worksheet.